Video number 28, workshop on panel data using STATA. The data I'm going to use here, the link is provided in the video. I have already carried out panel data using R, and you can read the whole document from R Markdown document link given in the video, and the video I have uploaded using R link is also given in this video. Okay, let's take a data, and at the moment I have STATA data available here, so I'm opening STATA data. So therefore we have data, National Longitudinal Survey data, DTA, from 1979 onward, or it's almost 18 years data. You can browse it for more details. At the moment, how to set your data as panel data. So if you don't know the commands, just go to statistics. Here you have longitudinal data, panel data. Just set up utilities, declare data sets to be panel. What is your ID variable? Here ID variable is what is your time variable? We say our time variable is time. So it depends which variables are basically describing your data as panel. So it's an unbalanced panel, and now we want to describe this data. So instead of writing describe, you need to write xt describe for panel data. So when we write xt describe, so we have 18 years data, and we have 107 individuals. So we have these variables. We are just taking using three variables. One is earnings, other one is married, and other one is soon married and single. So basically when you have three categories, you are omitting one category, or you can, so the question you can read in detail from Introduction to Econometrics by Christopher Daugherty, that whether married male earn more than single. So is it marriage which leads to more responsibilities and all that leads to more earnings, or is it कि जी जिनकी पत्नी, जिनकी बीवी, जिनकी जोरो, जिनकी वो जो है, they think that those who are picked up by employers are smarter than those who are not picked by the employers. So क्या वो दोनों employer और बीवी, पत्नी, जोरो, wife, they all pick both people they consider as smart or not. And you can read that. At the moment I am basically describing how to run this. We need to generate one variable, LG earn, which is log of earnings. So log of earnings, we have generated this variable, and now we regress. We do three models. One is simple OLS, another one is fixed effect, another one is random effect, and then we compare fixed effect and random effect. LG earn on married. If you don't know how to write here, just click here on the variable married, soon married. This is a panel data. Those who are single in this time period, after 3 years they will get married, and you compare them with single, and you can use robust standard errors. So these are the OLS estimators, 0.194 as compared to single. Okay, now we need to use fixed effect model and random effect model. So the command is not regress, it is xt regress, and rest is same, that is LG earn, married, soon married. Okay, fixed effect, FE means fixed effect, and robust standard errors. Okay, that's fine, it runs. Okay, no, same command, instead of using fixed effect we are using, okay, first of all estimate stores. Okay, please store these results, estimates, store fixed, because we have to apply Hausman test, and then no, again this is random effect, call random effect. Okay, no, again fixed, instead of estimate store fixed, we go to random. So now we apply a Hausman test. Whether there were two conditions mentioned in my video number 27: when to use fixed effect model, when to use random effect model. I'm not going to go in each detail at the moment, so that video is not very long. Okay, Hausman fixed sigma more. Okay, some error. We see reversed or p-weighted data. Okay, I have a do file here, so I instead of using the correcting command, I am going to regress it for you, and log of learn is not found, so we need to make it this one as LG, this one as LG. Sorry, it's getting prolonged. You can skip few steps here. LG, because we have a variable LG there, and here we have LG. Okay, let's run this. That's okay. Now you see Hausman test is rejected. So it means that your alpha I variables, there were two conditions for random effect model to be valid. First one was that your sample should seem as random from population. So these individuals from a large population seems a random sample, whereas second condition that those alpha I, those omitted unobserved factors, should be independent of your X, which is not the case. Therefore, you have to live with fixed effect model. And finally, you can bring these results in this STAB, and you see you can